For this example, we want to determine the fastest you could go on wet pavement with at most 100 feet of stopping distance. So for this example, we're coming back to that idea I set things up with. I gave some motivation for this section with at the beginning, where that means we want to solve the polynomial inequality 0.0875x squared plus 1.9x minus 88.4 is at most 0, where we kind of can skip that first step because we already had it set up like that earlier. Then from there, we want to find where this thing, treating it as an equality, would actually equal 0. That is, we want to find the roots of 0.0875x squared plus 1.9x minus 88.4 is equal to 0. And to do that, hopefully at this point people can recognize we don't want to use something like completing the square or factoring. We're kind of stuck with the quadratic formula. We're stuck looking at negative 1.9 plus or minus the square root of 1.9 squared minus 4 times 0.0875 times negative 88.4 all over 2 times 0.0875. I'm not going to write that all out here because it's clunky, and you guys hopefully do recognize that and can plug that in for yourselves, where what you'd end up with is something like x is equal to negative 44.445 or 22.731, where in this case we are specifically talking about potential speeds that a car can go. So it really doesn't make sense to consider a speed of negative 44 miles per hour, at least not in the context we're viewing it here. In this case, we don't have that distinction that you may see later in physics classes between what's called a scalar and what's called a vector, a thing having direction or not having direction. Here we're just talking about how fast a thing is going, so you can't have a negative measurement of how fast, which means we don't actually care about the negative 44 value. We only care about the potential 22.731, which means that we're going to be breaking this thing down into intervals from 0 to 22.731 and from 22.731 and beyond, where it being included from the non-strict inequality means we're a little bit fuzzier about that boundary value, but we end up with a number line something like that, because again, 0 is by definition our lower bound instead of negative infinity because you can't have negative speeds. And if we want to pick something for that lower interval, for the interval from 0 to 22.731, 0 is in there. It makes sense for how this is going to work, but even if it didn't make sense, you do want to pick x equals 0, because x equals 0 is very easy. We would have f of 0, or 0.0875 times 0 squared, plus 1.9 times 0, minus 88.4, which is just going to be 88.4. And that is, negative 88.4. And that is definitely at most 0, where because that is at most 0, we have that f is negative on the interval from 0 to 22.731, which is what we want. And that should make sense, because remember 0 is an amount of miles per hour. It's kind of silly to think about it in this context. You wouldn't really include 0, but it kind of is included in here. That you're fine for being able to drive that fast with less than 100 feet of stopping distance in front of you. On the other hand, if we look at the other side, for the interval from 22.731 and beyond, where because that non-strict inequality happens, we need to be careful about whether or not we need to include this point, so I'm throwing it into both. We can pick anything. We don't really have any particularly good options. You could use 50 or 100 or a million if you wanted to. It might make it clearer to you if you think in those terms, but I'm just going to pick x equals 23 because it's close. That gives us f of 23, which I'm not going to write out in its entirety, but what we would end up getting in this case is a value of 1.5875, which, importantly, for our purposes, is bigger than 0. And because that is bigger than 0, I already wrote the x as kind of a spoiler, but hopefully you are starting to get the idea here. F is positive on the interval from 22.731 up to infinity. And really, I should transpose that x down to here, because what that means is that the car would be driving too fast to safely handle that stopping distance. So, if you want to sort of put this together, we could say that if you only have 100 feet of stopping distance, then you should drive no more than 22.731 miles per hour. Or, if you want to think about this in terms of that number line, we could fill in that gap in the middle, looking at that range from 0 to 22.731. Where the next thing we're going to do with this stuff is talk about our close family of the polynomial functions, the rational functions, to instead look at what are called rational inequalities, naturally.